Hi everyone, thank you for joining us today for this webinar from Varnish Software on how to secure content at speed with Varnish Enterprise. My name's Ian Vaughan and I'm a product marketing manager here at Varnish, and I'll be hosting today's session. We're also going to be joined shortly by a special guest, Tace Ferrin, our technical evangelist, who will go into some detail in depth on the ways that Varnish implements TLS when accelerating content delivery. Tace literally wrote the book on Varnish, so it should be a very informative and entertaining session. Just to go through the agenda for today, we're going to talk about some of the challenges of content delivery at speed, especially taking into account security threats and regulatory obligations, followed by a look at the 4 different ways that Varnish Enterprise can secure customer and business data as it does what it does best, which is delivering HTTP content at super high speeds. So to summarize in advance, these ways are various access control mechanisms, cache encryption, web application firewall, followed by Tace's deep dive into TLS. And these features all have multiple applications as well, so we'll take a look at some use cases with each of these as well. And there's time for a Q&A at the end of the session, so if you do have any questions, just please do put them into the question box and we'll answer them at the end of the session. I think beforehand we should take a quick look about who we are and what it is that Varnish Software do, just to provide some context around our background in this space. So we're a leader in large-scale content delivery solutions. We develop and provide powerful caching technology that's used by some of the world's biggest brands and content providers and businesses to deliver super fast web and streaming experiences to potentially huge audiences, and mitigating the risk of downtime and loss of performance as you're handling unpredictable audience numbers. So it's really about solving these modern challenges around delivering things like HD video globally to potentially huge numbers of simultaneous viewers with minimal latency and without overloading the core infrastructure with requests for content. And as well as the streaming aspect, there's high performance web content delivery with real-time updating, and it's used heavily across news and media organizations, as you can imagine. And we'll go through a bit more about how the tech works in a sec. Varnish Software was founded in 2010, and it has its origins in the open source world, but now operates globally with offices around the world, and we're headquartered in Stockholm. The core technology is Varnish Enterprise, and this is built on top of the open source Varnish Cache, but really optimized for tier 1 organizations and for these challenges around streaming, CDNs, and web acceleration. This core technology is packaged into 3 different solutions for solving different challenges. So there's Streaming Server, which is for delivering live OTT video on demand video, DIY CDN, which is for building customized CDNs using pre-built, pre-optimized components, and Web and API Acceleration, which is about delivering dynamic, static, and personalized web content really, really fast. And a lot of the stuff we'll be talking about today is focused on Web and API Acceleration, but the topics and the security around the technology certainly have relevance for all kinds of content providers and the different versions of and solutions of our software. We do have a previous webinar which is available on DIY CDN if you wanted to check that out, and we will have an upcoming one in April about streaming, so be sure to check that one out if you're interested. Before moving on, you can see a few of the enterprises we work with, the logos there. So I hope that gives an idea about the wide range of industries and sectors that Varnish works in. It sort of hints at the versatility of Varnish Enterprise because it's just super flexible. And I know some of you on the call will be very familiar with Varnish Enterprise. Some of you maybe just starting out, maybe you've used the open source version, or you're just interested in finding out more, or you've got a new challenge that you're facing with content delivery. So I'll just go through a bit about what it is that Varnish Enterprise does and how it works. So it's essentially a powerful web cache and reverse proxy, which is a description that maybe sells it short a bit in terms of the sheer number of use cases it has, but for all intents and purposes, it functions as a caching layer that sits between your web servers and your users, taking a copy of content as it passes through the first time that a user visits your web or streaming service. And future requests for that content can be served by the cache instead of your web servers, right? So it's reducing bandwidth requirements and server load while improving the client response times. And so the result is obviously really fast content delivery that satisfies your end users, fewer backend resources required, and a layer of protection for your origin servers. So it's just enabling you to stay online and to continue delivering low latency content, whatever happens, whatever audience size you have. And it's designed for extreme performance. As you can see, you can have a 30 microsecond website response, can handle 100,000 requests a second. And as you'll see in a sec during Tase's presentation, we're now able to reach up to 150 gigabit per second from a single commercial off-the-shelf server. So it's really some of the highest performing technology out there for content delivery, and it's certainly the most resource efficient, thanks to its development history, the philosophy behind it, and it's the sort of open source flexibility, which gives the ability to really fine tune to specific use cases, and all the while being completely lightweight in the way it does things. And Varnish Enterprise is really optimized for enterprise organizations. So it's providing the features and functionality and those intangibles that larger businesses require when they're investing in any technology. So you've got the high performance, you've got the huge feature set, including massive edge storage, persistence, high availability, things like that. The enhanced security, which we'll talk about today, and also intangibles like support and professional services, which are really important for sort of designing, sizing, implementing Varnish Enterprise into any sort of complex environment, delivering any kind of HTTP content. And I think it's those aspects that really set it apart from other content delivery technologies that are out there. The team here are world-leading experts in caching and the content delivery space because they've been involved in Varnish since the beginning, and they've been hands-on for the wide range of enterprise deployments that we've been involved in. So it's about catering to those needs when the ability to deliver content is perhaps critical to revenue and reputation. So I hope that's been a okay sort of short summary. Of course, if you have any further questions, please do drop some questions in the Q&A box, but I think we'll carry on to today's topic, which is around the challenge for delivering content across your web services during high demand that potentially puts pressure on your infrastructure. I want to make a distinction here between the sort of maybe the classic usage of Varnish, which is delivering external web content, so accelerating web pages and particularly for Varnish Enterprise delivering video smoothly. But there are also many challenges within businesses that maybe people don't realize Varnish Enterprise can assist with. So speeding up any sort of content or data delivery within internal networks. Not to dwell on the sort of current global situation either, but I think we could all see that these sort of challenges have never been more real, where more people are at home, accessing the internet, using streaming services, using like so there's this higher usage of this usual external facing web services, but also people need to connect remotely to internal web portals or APIs and stuff like that. So there's that double challenge at the moment. that makes it quite prescient. So I think to focus on customer web services for a second, we can think about how people expect to be able to access web content to get the latest information in real time without latency. And adding even small amounts of latency to the web experience can actually put visitors off using your website and lead them to visit an alternative. So it's kind of critical that latency is always kept low, particularly when you're dealing with sort of real-time updates and high demand. So you can picture sort of breaking news stories at the moment with very short time to live settings, or other domains such as sort of gaming platforms where people expect live updates. So it's crucial to refresh content regularly. So we're sort of avoiding there is the sort of user frustration and the lack of responsive web experience that, while risking your infrastructure, can also put off your audience. I mean, so that's perhaps the most visible aspects of Varnish. But in terms of internal processes and your own organization's sort of internal networks, there's all sorts of things that Varnish can be applicable for. And there's lots of challenges around sort of financial transactions, maybe accessing market data via terminals or various API calls where they require high speed, low latency, but it also are situations where a lot of people, a lot of staff, particularly large organizations that are spread out, maybe trying to access the same information at the same time. And especially in industries like finance, where open banking has really widened the playing field, greatly increasing the number of sort of APIs that are being used. And it's all about now being able to deal with the flood of API traffic that's out there. But for these financial firms as well, it's going beyond things like cashless direct payments and transactions, but what about authentication, authorization, any regulatory tech engines that you have for anti-money laundering, fraud detection, anything like that that requires lots of data throughput and real-time updates. You may find that actually in periods of high demand, you're experiencing slowdown. And actually, just to focus on that sort of world, a lot of organizations that are highly regulated are very large. There is that struggle with legacy architecture, both hardware and software, where you're actually looking at moving to new technology, undertaking massive digital transformation projects. It's one of those things you need to be very careful with in terms of how do you do that while maintaining the ability to deliver content internally, and that also links to the security aspect that we'll get into in a minute. So in terms of keeping content available, up to date and accessible, this is really the exact problem that Varnish can solve. So again, think about the current situation where working patterns may be more distributed or clustered around individual cities, but no longer in the same office, but also people spending more time at home, so streaming service and internet usage is vastly increased. This diagram is basically just giving you an idea of a possible configuration for Varnish. So you've got two layers here, but you can be in one layer, or you can scale horizontally. There's all sorts you can do. At the edge, the edge layer, we can cache content closer to the users, whether that's customers visiting your website or staff accessing your internal networks or web portals. And this edge cache can store vast amounts of data, it scales easily, and it's mainly you can push computing power to the edge, right? So we have our programming language, Varnish configuration language, or VCL, which lets you customize and control everything. But this allows you to do that from the edge rather than taking up back-end resources. So it's just that constant improvement and efficiency that Varnish Enterprise provides. And then the origin protection layer, in this case, it's protecting the back end from unnecessarily high numbers of requests, which can obviously cause slowdown or failure. And it can do things like request coalescing, which combines requests for the same piece of content and only goes to the back end with one request to fetch it. So you're massively reducing the pressure on your resources. And so there's actually, you can see other cost management benefits there too, where maybe you need fewer server resources going forward because Varnish is sitting in front of your backend server. So just to maybe talk a bit more about VCL, which is the programming language and platform that makes Varnish so flexible. It's basically the way we allow and enable complete customization and control of your caching and content delivery. And it's simple to push changes out in real time. And a lot of the features you'll hear about today are based on easily implementing rules in VCL. So it's basically what makes Varnish Enterprise a true edge computing platform, because it's moving all of that computation out of the origin and close to users. So we've been talking about some challenges around keeping content flowing through your web services quickly during high demand. But now we're adding the next challenge, which is how do you do that, but also deal with the challenges around security? And I think it's interesting to think about the balance between that. So how do you keep content delivery reliable and fast without sacrificing security? And how do you keep systems secure without locking them down so much that data transfer, content delivery are actually affected by that? And I think it's about finding that balance and having the best of both worlds, and that's what I think Varnish Enterprise does. And I'd say there are perhaps three components here. So there's the need to protect sensitive user data as it's traveling from their devices to your backend and perhaps back again. The need to protect your own critical infrastructure from bad actors or malicious requests. And I guess related to all, these are all related, but there's also the need to meet any specific regulatory requirements, so GDPR, PSI, or CCPA, which are a few of the bigger pieces of regulation. So we're talking about here the sort of technical complexities of delivering business critical data securely at real-time speed, but dealing with the ever-present layer of sort of compliance and legal restrictions there may be. So everything from handling data logging on your servers to encrypting a cache to restricting access to specific content can fall under that regulatory umbrella. And I'd say the answer with Varnish Enterprise is security by design. It's built with security in mind. Its flexibility ensures that it can be adapted to changing security needs. So if you want to go away with one message from today, it's that Varnish Enterprise accelerates content delivery and improves web service performance while also securing data and protecting critical infrastructure. So it's that best of both worlds. And it's why many organizations in heavily regulated industries use it, because it offers that quality web experience without sacrificing security for speed. What I want to do now is quickly go over a few of the aspects of the security features that it contains, just to give you an idea of the sort of things you can do. And obviously there's that flexibility. So there's huge potential, but hopefully I should give you an idea of what you're able to do with these features. So firstly, if we want to look at access controls, so we look at when users are trying to access your web services, there's all sorts of things we can do here. So there's geofencing, where you're able to block traffic based on the country. This could be for licensing purposes. Perhaps your services only should be available in a few countries, or perhaps there's national legislation blocking this. And I know this is particularly of note for iGaming industries and stuff like that, where actually, because the laws differ across the nationalities, national borders, you actually need to be able to lock it down to specific countries. There's IP address-based blocking, so using access control list objects for self-exclusion lists in the sort of If we're thinking about iGaming, that people are able to add themselves to self-exclusion lists, so we need to restrict their access. Or if we're blocking access to internal web portals, blocking bad actors at the edge before they even get inside the network, or limiting access rights to different IPs and subnets. And actually, finally, on this section, the latest version of Varnish Enterprise has added support for JSON web tokens. So this is really adding a building block for integration with single sign-on, API gateways, microservices, and paywalls. So it's adding just a super powerful feature and ability to further add a layer of authentication and security into the flow before any of the requests enter your network. So if we move from user requests to the cache itself, we have Varnish total encryption. What this means is that cache data can be encrypted at rest. It's a really interesting way it does this with a sort of dual key encryption algorithm, with one key securely stored in the Linux kernel, the other key is generated from the client request, and no keys are ever stored in Varnish or in the cache. And every object even has its own unique key. This is really preventing an entire class of cache vulnerability, the cache leak. And you'll have heard of Cloud Bleed and Meltdown, which came about because maybe caches are uniquely vulnerable because they're designed to store large amounts of data with easy access, right? And they're designed to be fast and not locked down. So cache encryption is really important for protecting any data that's in the cache. And for Varnish, it works with all storage types. You can encrypt the memory, the disk, even the headers. It's actually very simple to implement as well. In VCL, it's one line of code that you can use to activate it. But you also have, obviously, the sort of trademark flexibility in choosing master keys, what, when, and where to encrypt and decrypt, and the option of having multiple master keys as well. So just also that it works in streaming mode, so you can produce encrypted and decrypted response streams. And it's just another aspect where we're securing and protecting data throughout the sort of content delivery process. And obviously, Tace's web presentation on TLS will go into another bit of sort of more detail on that. So looking at security in transit, as well as with the encryption here, we've got at rest. So moving from the cache, we can look at the final aspect here of the built-in web application firewall that Varnish Enterprise contains. This is when requests are heading to the backend infrastructure, and this can contain business critical data as well as sensitive customer data, and it's basically naturally the target of bad actors and malicious requests looking to gain entry to steal information or bring down the infrastructure. So it's adding a web application firewall or WAF to Varnish is just natural because we're already protecting the origin from too many requests. So implementing the Varnish WAF also keeps the backend safe from predatory traffic. And it's based on mod security, which sort of provides signature-based real-time HTTP request and response analysis. And it supports all the mod security features and the full rule set, which includes the full OWASP core rule set, so protecting against some of the most common attack vectors like SQL injection and cross-site scripting, and as well blocking attacks based on any security flaws in web applications, because I know sometimes businesses are stuck using legacy applications which could open up security risks. So being able to block attacks based on that while continuing to use this sort of critical application is really important. And obviously VCL provides complete flexibility for adjusting the security logic, setting your own security rules, including sort of rate limiting, which is useful for preventing DDoS attacks, and you can pretty much detect it and push out any sort of rate limiting measures really quickly using VCL with just some simple lines of code. And yeah, I mean, it can also be useful for if you're using any external CDNs as well. So it's kind of a fully fledged piece of technology in itself, and it comes as part of Varnish Enterprise. And I think that's the interesting thing about these security features is you're actually able to maybe even streamline your technology stack because these things are coming as standard. Maybe you're able to minimize the number of hops in your network because everything's integrated into Varnish, and you're able to continue that high-speed content delivery while protecting data and staying online. So that was a run through of 3 aspects of the security features in Varnish. What I'm going to do now is pass you over to Tace Ferrin, our technical evangelist, who will be delivering a presentation on the uses of TLS in Varnish Enterprise. So if you bear with me one moment, just make him present it.
Hi everyone, this is Tace. Just bear with me 1 second. Just have to switch my screen. There we go. I hope everyone is well in these crazy times we live in these days. I'm a technical evangelist at Varnish Software. My name is Tace Ferrin, and normally I would be doing this all around the world, but from now we're doing this from the safety of our own homes, and I hope everyone is well. Now, my job is to tell you a little bit about TLS in Varnish. But before I can actually do that, I have to talk about the Unix philosophy. And the Unix philosophy says that you have to do one thing well. Now, the consequence of that is that you focus on one piece that is your core business, and you let other tools do other little things. And to solve the problem, you just join in all the tools, let them collaborate, and that's how you tackle it. We love this philosophy and we adhere to it. And our little thing, it's not a little thing, actually, it's a big thing that we do well, is of course, performance. Now, performance, it's not all about speed. Performance as such is making sure it goes fast, but there's a couple of side effects that we have to keep in mind as well. Side effects that are quite important. Maintaining speed at high load, which we call scalability, is very important. And another side effect of that being the stability that you get by doing this is equally important. So although we focus on speed and performance, the side effects are stability for your company and being able to scale along with capacity needs. In the vein of that Unix philosophy, doing one thing well, the interesting thing is that historically we did not support HTTPS, we did not support TLS. The mindset at the time, and that came from the open source project, was we need to focus on performance, and everything that can jeopardize performance will not be supported, or at least will be put under heavy scrutiny. And initially, OpenSSL, the library that a lot of software uses to offer HTTPS, to offer TLS, was not deemed either secure enough or stable enough. Now, that was back in the day. There was a reality that you can't really escape from, being that TLS is everywhere. You can't really ignore that. And saying as developers of Varnish we're not supporting TLS is not living in the real world. And there's tons of initiatives, even initiatives like Let's Encrypt, that have democratized the use of TLS certificates and that basically have made it free to use. So we knew that we had to do something about that. And fast forward to 2015, we came up with a solution that tackled this issue, but that still keeps our Unix philosophy love in mind. Instead of straight up implementing TLS in Varnish, we decided to develop a piece of software that would be uniquely suited to deal with TLS. So we developed a dedicated SSL and TLS proxy called Hitch. Now, I'm sketching this as though this is a thing of the past. Hitch is still very relevant to us. Hitch solves this one problem, SSL and TLS proxying, and just sends the rest to Varnish. So sends unencrypted traffic to Varnish. And the best way to show you is by showing you this little sketch, this graph. Whereas Varnish is connected to the server and will proxy data through, we still need to deal with HTTPS connections. The way we tackle this is by putting a proxy in front of a proxy. So Varnish is a proxy, but Hitch is also a proxy. Hitch speaks HTTPS with the end user, decodes or decrypts, make sure that the traffic is sent to Varnish, and then Varnish can choose to either send it to the server over HTTP or over HTTPS. The thing you need to know is, although I am describing Hitch and Varnish as two separate physical machines or virtual machines, in most of the cases, they're separate services hosted on the same machine. So that HTTP traffic can be done over TCP/IP, but can also be done over Unix domain sockets, further increasing the performance. What is very interesting about Hitch is that it is a TLS proxy. It's not an HTTP proxy. In fact, it doesn't even speak HTTP. Consequence of that is it's ultra lightweight and hence very, very powerful. And again, from the Unix mentality, the Unix philosophy, do one thing well, we've built it for the job. To that extent that initially we were able to get more than 100 gigabit per second per server over TLS, which we're very proud with. So that was the situation when we started out in 2015. Now, when you want to play around with Hitch, or when you want to use Hitch, there are several ways of getting it. Hitch is open source software. You can get it free of charge at hitchtls.org or at our GitHub release pages. The Debian and Ubuntu distributions of Linux even have packages that you can use. Using apt-get install, you can automatically install the software, and pretty soon we'll have a Docker image out as well for those who want to use it. Now, today we're going to talk about Varnish Enterprise and how Hitch is and TLS termination and TLS handling is done in Varnish Enterprise. Well, if you are a Varnish Enterprise user, you'll have packages as well. Packages that are not necessarily maintained by the open source, but maintained by our engineers with our specific goals in mind. Now you see that we have packages for both Debian and Ubuntu and Red Hat, CentOS, and Fedora. Cool thing about this is if you get your packages through us, we'll maintain them. We'll make sure there's occasional bug fixes. We'll make sure that security updates come in as quickly as possible. So basically you are maintained. And if you get a Varnish Enterprise solution and you need to install Hitch, we'll do that automatically for you. Now, if you're more, if you want to do this in the cloud, or if you are more accustomed to self-service model where you want to do things yourself, we have official Varnish Enterprise images on the big tree, on the marketplaces of both AWS, Microsoft Azure, and Google Cloud. If you fire up a server using one of these images, Hitch will be pre-installed, as well as Varnish. Everything will be ready to go, and we'll even have a dummy certificate ready that has to be replaced, of course, with your certificate, but that you can already try out HTTPS connections. Since this is a tech session, or a more technical session, I will show you how Hitch can be configured to your likings or to your needs. It all starts with a configuration file, the hitch.conf file, that has a sort of syntax. Now, let's not focus too much on the details. I'm going to pinpoint a couple of things. On top, you'll see that we have a front-end definition. This is how we get connections, inbound connections. In this case, we're listening to all hosts on port 443. Now, for those who are tech savvy, those will know that port 443 is a conventional port number that is the equivalent of HTTPS. So that is HTTPS traffic coming in. What we also do is we define where this traffic should be sent through once it's decrypted. And in this case, Varnish is hosted on the same machine. So we're connecting to the local host on a semi-conventional port. It's a port that we like to use for this kind of traffic. It's port 8443. So all of a sudden you have defined how connections should be accepted and where they should be sent to. And then there's a host of other configurations. But the main thing you probably want to know is, what about certificates? How do I put my certificates there, the things that matter for the verification? There is a specific configuration directive called the PEM file, and that points to a file on the disk on your server where your certificate is hosted. This is what it looks like. Now, it might seem very scary, especially the left part. Please don't focus too much on all these weird characters, all these certificate things themselves. Focus on the boundaries, focus on the headings. You can see that there's a certificate in there, begin certificate and end certificate, and also a private key. Whereas the certificate represents the public key information, the private key, of course, what's in the name will represent the private key information, and there's a bunch of other parameters. Long story short, this is just a file where all your certificate information can be stored in. In case you have multiple certificates, you can issue multiple directives of the PEM file and point it to different files on your disk. The interesting thing is that we will automatically match them to the right host name of incoming connections. This protocol called SNI, server name indicator, will allow us to debug the connection, figure out what host you're trying to connect to, and match it to the right certificate. You have different ways of configuring it. You can do it per file. You can also specify a directory where your certificates will be stored, and then all certificates will be loaded unless you use this PEM-dir glop. PEM-dir glop means that you can match certain patterns, certain files. So in this case, we're not loading every file in the cert.d folder, but only the files that end with PEM. So you have pretty good control over which files are loaded if you have multiple certificates. If you want to do it a little bit more granular, you have an extended configuration syntax for the PEM file directive, where you can split up where the certificate itself is hosted and where the private key is hosted. So you have a lot of flexibility in terms of PEM file configuration. And as you might have seen in the previous slides, but I won't focus on that too much, is you have tons of ways of defining which algorithms to use, which security parameters to use. But the way we configured it is pretty standard. And again, if you go to the documentation page and you want to tweak it yourself, you have the opportunity to do so. So you might think, yay, yet another service to manage, and yet another hub my traffic needs to go through. And although that is true, there are benefits to it. And of course, we try to soften the blow by implementing some industry standards that do this. One of which is the proxy protocol, which will come to the rescue and make things a lot more transparent and a lot easier to use. So if you look at this image, you'll see the typical flow where the server is there, the origin server, where Varnish is present, where you have Hitch to terminate TLS. And where you can see that by enabling proxy protocol between Hitch and Varnish, which is a specific protocol used to transmit the original IP address of the original client, Varnish, regardless of the number of hops that sit in front of it, will always have the right IP address. And then can set an X-forwarded 4 header, as that's called. That's a conventional HTTP header that indicates what the IP address for the original connection was. So as a developer or as someone who runs a web platform, you can then look for that IP address, and that's how you identify users. And the proxy protocol, which can be enabled in Hitch as such, will deal with that for you. So it's a way of softening the blow. It's a way of making adding extra hops in the network a lot easier and a bit more transparent. So that's Hitch. And then you come in contact with clients that say, hey, very nice solution you have there, but 100 gigabits per second per server is just not enough. That actually happened to us. And then we had to rethink our strategy and think where we could shave off some overheads and gain more performance. And it was clear that the termination part, although it was very secure and a very in the Unix mindset separation of concerns strategy, in core TLS or native TLS was the way to go. It was the way to push those boundaries of performance. And again, graphically sketched there with this release that came out yesterday, by the way, that should be 606 R2 of Varnish Enterprise. We support HTTPS natively in Varnish, meaning you no longer need Hitch, and Varnish can directly accept HTTPS connections as well as your regular HTTP. And the way we did this, I also found particularly interesting, is by basically eating our own dog food, as they say, is we use a subset of Hitch's configuration mechanism to configure HTTPS in Varnish. So if you have a configuration file like this, prior to using in-core TLS, you could just recycle that and we'll play ball and we'll make sure we read this. All the directives we support will process, and the ones we don't support, we won't fail on, we'll just ignore. In this example, you see that there's no backend definition there. That's because you don't need a backend definition in your TLS configuration. Varnish will handle that itself. Just an example. How do you tie those together? Well, in our process, this is the Varnish binary, the Varnish process with a bunch of startup parameters. We added a new parameter called -a uppercase, and that refers to your TLS configuration. Now, please don't confuse it with -i lowercase, which is used to define ports. Speaking of ports or listening ports, you can see that I opened up -a:80. So that means we're listening on all network interfaces on port 80. And port 80 is a conventional HTTP port. You do not need to open up dedicated ports for HTTPS. It is done in your front-end configuration, which you can see here if I go one slide back, and Varnish will handle that automatically. So it's just a matter of adding a simple -a uppercase configuration parameter and linking to a TLS configuration file that might be brand new for you, or that might be recycled if you use Hitch. And the upside of this is that we, by doing this, can process more than 150 gigabits per second per server. And we're very proud of this, of course. And we can say that this makes us faster than competing products in the industry. And even while being faster, we consume less server resources. So it's an ideal solution for people who want to push the boundaries and want to process at really high concurrency, at really high speed. There's caveats to it, as always. In order to run in core TLS or native TLS, you have to have OpenSSL version 1.1. OpenSSL is a common library that does the cryptography part. So please check your Linux distribution to see if you have the right version. Now, it's minimum v1.1. If you have a more recent version, there is no issue. For your convenience, I've listed a couple of distributions that are supported, at least. So you have Red Hat Enterprise Linux version 8. Its open source counterpart CentOS version 8. If you go to the Debian distribution family, you have Debian 8 codename Jesse and Debian 9 codename Buster that's supported. And if you're an Ubuntu person, version 18.04 codename Bionic will all support it. Otherwise, you'll either have to switch distributions, or if you're up for it, if you're brave enough, upgrade your OpenSSL on your distribution. Now, what's also important to know is that we haven't developed this for everyone. Although it's very convenient and it's faster and it's easy to configure and there's one less hop, we didn't develop it for everyone. We still believe that the normal approach, including Hitch, is still part of our reference architecture. It's still the thing we will advise to clients. So with that in mind, why would you choose for a native TLS implementation? Of course, speed. Speed is an easy one, low-hanging fruit in that case. We can go beyond the 100 gigabit per second per server that we had using Hitch. We can go more than 150 gigabit per second per server. Another use case, if your Hitch service that you have to manage would be burdensome for you. If you say simplicity is very important for us and one less service to manage would make a huge difference, then by all means use our native TLS implementation. But I still want to stress that Hitch is very secure. It's extremely secure. And it's again from that separation of concerns mindset that you could secure appropriately. Hitch runs under a different Linux user than Varnish. It is separate. If anything would happen, let's say hypothetically, of course, that something would happen and that there would be another hard bleed vulnerability in OpenSSL, then only Hitch would be impacted. That's not saying this will happen, but from an extreme security point of view, having separate processes with separate concerns is a good idea. But of course, if you value and if performance and scalability is super important for you, by all means, use our in-core TLS. And then another question I would like to answer is there end-to-end encryption policy potential? Is there a potential to have end-to-end HTTPS? Can we connect from Varnish to our origin server using HTTPS? And the answer is yes. I already hinted towards that in the diagram in the beginning of the presentation. So it's just a matter, and this is the VCL code that Ian talked about in the beginning. This is a file where you define not only backend information, but also the policies and how to cache. What I highlighted here is how you define how Varnish needs to connect to the backend. So we see host name and port information. But what I'm doing here is enabling SSL with a configuration flag, setting SSL to 1, making sure that connections from Varnish to the origin server are made using HTTPS. What is interesting about this looks very normal, but this is an enterprise-only feature. The open source version does not support SSL connections from Varnish to your origin server. And basically, that is what it's all about. Varnish Enterprise really tries to tackle issues that, as Ian described, tier 1 organizations really care about. And we're very happy that we have in-core TLS. But my goal was not only to showcase in-core TLS, but also to show how we deal with TLS in general, what the configuration is all about. And I'd like to thank you for sticking around, and I'll give it back to Ian for Q&A.
Thank you very much, Tace. That was really good, really informative. I guess it's just demonstrating like the importance of having the choice, right, in Varnish Enterprise. There's different ways of doing things depending on your specific needs of your pricing, security or speed or whatever. You can find the right balance for each individual use case. So just going to take a look at see if any questions have come in. So we've got some time for a Q&A. So if you do have any questions, do put them in the box. I'll just take a look and see. And Tace, if you wanted to stick around to maybe answer some of these questions. Give me one moment.
No problem.
So the questions come in. Perhaps you could also explain this concept as well, but someone is asking if it supports OCSP stapling.
It does. We support it. Now, OCSP stapling is a protocol, or OCSP is a protocol that is used to check if certificates are revoked. It could be that for some reason, an issuer or a certificate, someone who has TLS services wants to make sure that a TLS certificate is no longer valid. There's a protocol for that. OCSP stapling makes sure that in order to avoid that the browser has to make an extra round trip to this certification server to figure out whether or not the certificate is still valid, we can do that for them and staple, hence the metaphor, staple the response of the validity to the HTTPS response, and making sure that the browser already knows whether or not the certificate was revoked, making sure that you avoid another round trip and increase performance and scalability. Now, yes, we do support that, and there are configuration parameters that I didn't include in the examples that allow to specify directories and timeout parameters on how Hitch, and specifically Hitch, can validate this. It's important to know that our in-core TLS does not support this. So feature-wise, there's two things that Hitch can do that in-core TLS can't do, one of which we just discussed, OCSP stabling, and the other one is dynamic certificate reloading. So if you have an update on your certificate, our in-core TLS solution can't dynamically reload it. So kill two birds with one stone there.
Okay, cool, thank you. Just to have a look at some more questions that have come in. So a question about whether inline TLS is an enterprise feature. And perhaps we could also talk about the other security features and whether they're Varnish Enterprise only.
Yes, indeed. So most of the things you've seen are enterprise only. The one feature that I can come up with that is not enterprise is of course access control based on IP addresses, host names, and subnets. But what you've seen in terms of total encryption, web application firewall, the in-core TLS, all of that is enterprise only. Hitch, of course, is free and open source. So if you want to terminate TLS at high speeds with Varnish, that's perfectly possible using open source technology. And what we can do both in open source and enterprise is connect Hitch to Varnish both over TCP/IP and Unix domain sockets.
Okay, awesome, thank you. Just got time for a couple more, I think. So a question about, is there prescriptive guidance on how to get 150 gigabits per second throughput from one server? So do we provide sort of support and
we do. Now this goes beyond the scope of what I do as a technical evangelist, but I communicate closely with both our R&D team and the solution architects who set these things up. And there's various ways of doing this, and it all depends on what you want to do. Of course, there's lots of kernel tweaking going in that and making sure you have the right hardware to deal with it. But apart from that, you can do things in your TCP stack as well. We've recently written a blog post on how you can use different congestion algorithms that also reduce overhead. So it's a ton of things. It's an array of things, and it's widely different for your use case. But I'm pretty sure, based on the experience we have with large-scale streaming platforms, big CDN providers, people who build their own CDNs, it is perfectly possible if you tune your Varnish correctly. Now, to answer your question very directly, if you're interested in going beyond 100 gigabits per second per server, you want to reach that 150 gigabit, please reach out to us, explain your use case, and we'll try to figure out a dimensioning of servers, the number of servers you need, and how we will tweak the kernel and the TCP stack to get you there. Now, mind you, this 150 gigabit per second was not a number we just invented or that came out of thin air. As I explained, the request to go beyond 100 gigabit per second per server came from one of our clients, which is in this case a big telco provider who offers media services, video streaming, and they tested it and went, I think the real number was 160 gigabit per second per server they reached. So in order to do that, you also need to have the server farm and the capacity to test it. But again, if you want to know, reach out to us and we'll help you with your individual case and describe in large detail how you get to that 150 gigabit per second per server.
Nice, thank you for that. I think we've just got time for one more. I guess kind of related is whether in-core TLS decreases hardware requirements, say the CPU and so on, compared with Hitch.
I can't really speak on that. I can ask the guy who developed it, one of my colleagues. He'll be able to answer that. And this question came from Carlos, I guess. I'll be in touch with you, Carlos, and we'll answer that. I have your details, and I'll figure that out. At first glance, I would say probably not. But then again, I didn't develop the code. My colleague Doug developed that. So I'll reach out to him, figure out what's going on, and provide you with an answer on hardware requirements.
Okay, thank you for that, Thijs.
There's another question that I would be happy to address. The question was, can I change the ciphers and the protocol to connect to my backend? Well, your backend needs to define which ciphers are available. So if you're talking about how Varnish connects over SSL to your origin, that will happen at the web server side. So you will tweak there what the ciphers and the protocols are that you want to use. However, if you want to configure how ciphers and protocols are supported to the client, you can definitely tune that in the hitch.configuration file. If you look at how Varnish connects to your origin server in terms of ciphers and protocols, Varnish is just the client. It supports the common ones, the main ones that are part of OpenSSL version 1.1. So if you want to make that very restrictive, there's no problem there.
Awesome. Thank you very much. Thank you again for...
I'm willing to answer a final one that came in. Question was that we don't support dynamic certificate reloads. No, you don't have to do a full Varnish restart to make this work. A reload will do fine. Reload does not empty the cache. It only reloads the process itself that accepts the connection. So you should be fine there. But however, not everyone is always that comfortable reloading services on a production server.
Okay. If we didn't get a chance to answer your question, I know there's lots of interest in core TLS specifically. We'll be sure to reach out after this session and just have a conversation with you about whatever you're interested in terms of implementing this. I want to thank Thijs for joining us today and going through your TLS session. That was hopefully really informative for everyone. So thank you for stepping in to do this.
And historically, if you look at it, it's very historical, because I remember in the early days, there was never a chance that Varnish would offer TLS natively, and I'm really happy that as Varnish Software we managed to make that happen. I think I can't really count the number of questions we've got from people throughout the last decade, because I've been using Varnish for over a decade, is when will you have TLS? When will you have that? And we can finally say, as of yesterday, it is in core. Although it's not available in the open source, it is available for people for who it matters, and all the other people will gladly use Hitch, I guess.
Yeah, and I think it speaks to the talent of the developers here at Varnish Software in terms of being able to make it happen, right, and being able to hit those sort of speeds. So also, I'd like to thank everyone for joining today. I know it's kind of crazy times, but we're going to carry on doing regular webinars on lots of different subjects. So I hope you are able to join us again soon for another session on sort of the sort of things that Varnish Enterprise can do, the sort of silent challenges it can solve. If you do have any other questions or queries, or just want to have a conversation about using Varnish Enterprise, do drop us an email or visit our website. So there's forms you can fill out and email addresses you can get in touch with there. But for now, I just want to say thank you very much for joining us, and have a good day.